Module 4, Topic 1, Repetition with VBA. One critical element of programming you need when working with data is the ability to repeat the same code segment multiple times. Not only does this allow you to accomplish a task where the number of times you do it changes every time, but it also makes your code more efficient. Let's examine the situation where you are performing calculations on a set of data from a CNC machine similar to assignment from Module 1. In addition to importing the data, you'll also need to add formulas to find the difference from the nominal position along with other tasks. What makes it more challenging is that the number of samples is different every time. It makes it harder to have one workbook that covers all situations, and you end up having to reapply the formats and formulas every time. With repetition in VBA, you can automate these types of scenarios. VBA offers two main methods to control repetition: for loops and do loops. Most tasks you can do with either method, but each has its own merit and own variations. For loop. A for loop allows you to repeat a code segment a fixed number of times. Let's take a closer look at what the code looks like. Here's an example where we're filling column A with numbers 1 through 10 on rows 1 through 10. Watch what happens when I run the subroutine for loop example 1. A for loop will repeat the code based on an incrementing variable. The first line of the for loop defines the range this variable will take on. In the example shown, the for loop uses a variable, iLoop variable, starting at 1, and it keeps looping until it gets to 10. Watch the value of iLoop variable as I step through the code using the F8 key. I'll add the variable to the watch window so you can easily see the value. The first line of the for loop includes the keyword for, which signifies the start of the for loop. Next is the initial value of the loop variable. In this case, we are starting with the loop variable equal to 1. Then the final value of the loop variable is specified using the keyword to. This loop will execute 10 times, once for each value between 1 and 10. The last line of the for loop is the next statement. When the next statement is executed, the loop variable is incremented. Did you notice at the end of the loop the value of iLoop variable actually went to 11? Let me show you again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The code segment will execute the 10th time, and when the next statement is executed, iLoop variable increments once more. But the loop doesn't execute again because the value is above the upper range defined on the first line of the loop. Inside the loop is the code segment that executes multiple times. Notice how I've used the loop variable within the code segment. First, to choose which row to access within column A, using the cells method. And second, to use it to give the cell a value. Let's watch the loop execute one more time. Notice how in the first loop, cell A1 is assigned the value from the loop variable, which is currently 1. In the next loop, cell A2 is assigned the value from the loop variable, which is now 2. This continues until it reaches the last iteration, where it fills cell A10. As you may have noticed already, the variable automatically increments by 1 each time. This is the default increment. You can change how much the variable increments by using the keyword step at the end of the first line. Let's look at for loop example 2. In this example, notice how I've added the keyword step followed by a 2. This means that when the next statement is executed, it will add 2 instead of 1. Let's watch this execute while I step through. Notice with the first loop, iLoop variable still starts at 1. Notice on the next loop, iLoop variable is now 3 instead of 2. When the line of code inside the for loop executes, A2 is skipped and A3 is assigned a value. When iLoop variable gets to 9, the code segment is executed, and the for loop is ended because the next value is 11, which exceeds the upper limit of the for loop. For each loop. The for each loop is a variation of the for loop. The for each loop is designed for when you have a collection of items, like a range of cells or an array, which we'll discuss in a later module. The for each loop executes the code segment for each value in the collection of items. Let's look at an example that uses a for each loop to cycle through a range of cells. This example uses a group of cells I've named group of cells. The for each loop will cycle through this code segment for each cell within the group. Let's watch it run. This for each loop takes the value from the cell, multiplies it by 10, and places the result in the cell beside it. It also colors the original cell yellow. The first line in the for each loop contains the keywords for and each. The next word is the loop variable called rCell. This variable will reference the value or object within the collection as opposed to the loop iteration value you saw in a regular for loop. Next, the collection is specified after the keyword in. In this example, we are referencing a group of cells named group of cells. When the code inside is executed, the loop variable is updated to represent the next item in the collection. If there are no more items in the collection, the loop is not repeated. Let's watch the loop run again, but this time paying close attention to the value of rCell. Notice that rCell takes on the value inside the cell, as opposed to the loop number. Also notice that it's not simply a number, but a reference to a whole cell object. This is indicated by the plus sign in the watch table, and if we expand it, we can see all the properties associated with the cell. In between, you'll find the code segment that's executed. In this code segment, you can use the loop variable to complete a calculation or perform a task, and you can also use it to change the properties of the object. This code segment in the example takes the value from the cell multiplies it by 10, and puts the result just to the right of the cell. It also changes the color of the cell itself to yellow. One essential piece of information you need to know about a for each loop and its loop variable is that the loop variable contains only a copy of what is in the collection and is essentially read-only. For example, if we were looping through a collection of text strings, we could change the value of one of the strings in our code segment, but then the value would be lost as soon as we started the next loop. It wouldn't change the value in the string collection, but it would only change the value temporarily. In our example, we're using a collection of object references, a named range that actually doesn't remember what is contained in each cell, just the positions of the cells on the worksheet. When we cycle through these positions, we could temporarily change what our cell references inside the code segment, but it doesn't change what cells the named group of cells includes. On the other hand, since the collection just contains positions of cells, we can permanently change the properties of cells that are in the collection. As you have seen, we can change the fill of the cell within the range group of cells, and the cells stay yellow. But if we tried to change the cell R cell to a cell outside the group of cells, it would only last for that one loop iteration, and it wouldn't change the cells that group of cells actually referenced. This concept will become more clear as we start to work with arrays later in the course. For now, just keep this in the back of your mind. Do loops. Sometimes you may need to execute a loop an undetermined amount of times. The do loop statement is another method of repetition that performs a continuous loop until a conditional statement becomes true or false. The options in the code all produce the same results, but there are 4 different styles of loops that can accomplish it, which we can fit into 2 categories based on where the conditional expression is located. Do loops with the conditional expression after the loop. In do loop example 1, we have a loop searching a list of names. When it finds the right name, it stops the search, exits the loop, and updates the note at the top of the next column to indicate which row Jack is in. Let's step through to see it run. Notice how the loop cycles through the first few rows, and then when it gets to the row with Jack, the loop exits. The last line of this version of a do loop has all the control. This version is known as the do loop while. The first line only contains the statement do. This signifies to VBA that this is the spot to loop back to. The last line is the line that determines whether to loop back to the top or exit the loop. It starts with the keywords loop and while, followed by a conditional expression. The combination tells VBA when to exit the loop. In this case, if the conditional expression results in true, the loop repeats. In other words, if S name is not Jack, repeat the loop. In between is the code segment that will execute. In this case, the code segment is guaranteed to execute at least once, since the condition to exit the loop is on the last line of the code segment. Let's watch how the loop executes if we put Jack at the top of the list. Did you notice that the loop actually didn't loop back at all? There are 3 other variations of the do loop. The next variation that closely resembles the do loop while is the do loop until. In the code example, do loop example 2, we have the same loop except we changed two things. Can you find what was changed? Let's run through the loop while you see if you can find it. Did you find it? If you need more time, feel free to pause the video. The first thing I changed in this version was changing the keyword while to the keyword until. The other thing I changed was the conditional operator that's between sname and Jack. When using a do loop until variation, the code segment will repeat until the conditional expression results in true. In other words, if the conditional expression is false, the program will execute the code segment again. The do loop while and do loop until can be used in the same way, and you can choose which one to use based on how you want to write your logical expression. Do loops with the conditional expression after the do. The other two variations of do loops put the conditional expression at the beginning of the loop after the do keyword. This means that there's a possibility that the loop will never execute at all. In do loop example 3, we use a do while loop. Notice the keyword while and the conditional expression is now on the first line. The last line just has the keyword loop. When the program gets to the first line, if the conditional expression is true, the code segment is executed. When the program gets to the first line, if the conditional expression is true, the code segment is executed and the program returns to the start of the loop. The conditional expression is then evaluated again, and the program decides either to skip to the end of the loop or repeat the code segment based on the conditional expression. Let's watch this code execute. First, I'm going to move the name we're looking for to the third row of the group. Notice the first two loops through, the code segment is executed. On the third loop, the conditional expression is now resulting in false, so the program jumps out of the loop to the next line of code. If we move Jack to the top of the list, how many times do you think the loop would execute? Let's watch and find out. Notice how the code segment isn't executed at all in this situation? The fourth example shows the do until loop. This is very similar to the do while, except the code segment will be executed when the condition is false as opposed to true. Notice that again we have replaced the keyword while with the keyword until. And we have changed the conditional operator from not equals to equals. If you watch this code run, you'll see it reacts the same way as the previous loop. Troubleshooting do loops. One word of caution when you're testing your do loops is that it's very easy to get caught in an infinite loop. An infinite loop is when the conditional expression never triggers the loop to exit. This is a very common occurrence when learning how to program with do loops. To handle these situations, your best strategy is to be proactive. Save your file before you test your program, and step through any do loop manually before letting your program run fully. Even as an experienced programmer, I forget to do this sometimes, and I end up in a situation where my macro tries to run forever and I have to force it to stop. To try to stop an infinite loop, there are a few keys you can press that I find work some of the time. These keys include escape and pause. Let's watch what happens if we run do loop example 4, but we delete Jack from the list. If we step through line by line, you will see that the loop doesn't end. If we hold down the F8 key for a few seconds, we notice that I row to check continues to increment well below the list of names. Luckily, since we're just stepping through the program, we can easily stop or reset the program by clicking Run and Reset. If we press F5 to run the macro completely, notice it will stop itself by producing an error because we reached the highest value an integer data type can store, and it can't be incremented by 1. If I comment out the lines of code inside the loop, our loop will not produce an error and continue to run until we find a way to stop it. Notice in the top of the window, it tells us that it's running, and we see the mouse change to a circular icon. If I press the escape key, it should interrupt the execution and allow us to pause or end the macro. Notice sometimes the escape key will not work, and the Excel will go to not responding. I find that sometimes it will work and sometimes it won't. Alternatively, you can try pressing the pause key or the Alt and pause keys at the same time. This should produce the same result, but again, sometimes I find this also doesn't stop my program. If you get into a situation where you can't stop the loop, your other option as a last defense is to force Excel to shut down. To do this, open the Task Manager by pressing Ctrl-Alt-Delete at the same time. Click Task Manager, and the Task Manager window should appear. From here, you can highlight the Excel program and click End Task to shut down Excel. The disadvantage to this method is that if you haven't saved your work in a while, you'll likely lose all your work since your last save. The key points to remember when testing do loops is to get in the habit of saving your program before you test your program. This way, if the escape key doesn't work like you just saw, you can still stop your program without losing any of your work. Exiting loops early. I mentioned earlier that in most situations, any of the loops we've discussed so far can be used. The way that you have a for loop act as a do loop is by using an if statement to decide to exit the loop early. Sometimes conditions may exist such that you don't want the program to wait until the loop completes on its own. A good example of this is completing a search. If the value is found, it's not necessary to continue the loop, and it may be a good time to exit. But if the value isn't found, you may want to keep checking until the end of the list. Exit loop example 1 shows a for loop that accomplishes the same thing as the do loops in the previous examples. Notice the if statement inside the for loop that checks to see if S name is Jack, and if it is, it uses the keywords exit for to exit the loop. Watch while we run this loop. Notice when we get to row 2, the if statement condition results in true, and the exit is for is executed. At this point, the for loop is exited, and the program skips to the line after the for loop. We can also use a do loop to accomplish what a for loop can do. In exit loop example 2, there is code that is similar to the first for loop example, but using a do loop. Notice I've removed the condition to end the loop, which would cause the loop to execute infinite times. To compensate for this, I've added an if statement to exit the loop, using the keywords exit do when the loop variable is greater than 10. Watch while we run this loop. Notice after 10 times, the if statement conditional expression results in true, and the exit do is executed. At this point, the loop is exited and the program finishes. Deciding on which loop to use. As I have shown you, you can use most of the different loops in any situation, but each loop style has appropriate uses. A for loop is great for executing a code segment a fixed number of times. You can use variables to replace the initial and final values in the for loop to make it dynamic. Another situation where a for loop is beneficial is when you need to loop a code segment that uses an incrementing variable within the code segment itself. The nice thing about using a for loop is that you don't need an extra line of code to increment the value since the for loop does it automatically. A do loop is great for executing code an undetermined amount of times. The advantage to this loop is that you can stop the loop based on a conditional expression. You can also combine multiple conditional expressions, so you can have more than one criteria for exiting a loop. If we think back to the situation where we ended in an infinite loop because the name Jack was no longer in the list, we could have a second condition to exit the loop if there are no more names in the list. Most of the times, the two conditional styles, while or until, of do loops are interchangeable. But you might find that based on the situation, one will be preferred over the other. Just remember that one will loop while the condition is true, and the other will loop while the condition is false. The overall location of the conditional expression with the do, either on the first line with the do or the last line with the loop, are also interchangeable for the most part. If you find you feel you need to have the code segment repeated before entering the do loop, you might be better choosing to have the conditional expression with the loop. That way, the code will always execute once before deciding to loop or exit. If you find that sometimes you don't want the code inside the loop to execute at all, it might be helpful to have the conditional expression on the first line with the do, so that the code can be skipped if the conditions are already met. That completes the video lesson for Module 4, Topic 1. Review the topic pages for a reference on the proper code syntax for the statements you learned today, and then complete the learning activity to try it yourself.